All right, and welcome to this little quick tutorial on 3D printing workflow, getting your model from SketchUp into something that you can print with. So I've got my blank SketchUp here. The first thing I'm going to do is to get rid of this ukulele guy here. He is not needed for our printing and can cause some problems later on. So we're going to get rid of him. And I want to create a very, very simple little shape and then kind of show you some of the problems that can go with it as well. So I'm just going to create a little cube here and let's say I wanted to put um, a little dent in it here like so. And I'm going to, I'm gonna leave it like that, just to show you some of the issues that can happen. So let's say this is a shape I wanted to create. Maybe it was for holding a servo or something like that, and I want to 3D print it. So the first thing we have to do is to make sure again that there's nothing else here. When you download your shape, it's going to download everything in SketchUp. So we want to make sure that only the thing that we want to print is here on our page. And then we're going to go down here to this download option. And we're going to create what's called a still, a stereolithograph file. This is, and if you hover over top of it, it'll say right there for 3D printing. This is kind of a universal file format to be able to use for 3D printing and kind of 3D modeling here. It's not really useful for editing much later on. They can get a little bit messy, but it is, once you're happy with it, you want to download the STL file. And that's just going to download into your downloads folder here. Mine's called Untitled 7. Once you've got your finished model and you've downloaded it, then what we need to do is take this into what's called a slicer. And each 3D printer has a different slicer, but essentially what it does is takes that 3D model and turns it into little flat slices that then get stacked on top of each other by the 3D printer. So we need some piece of software that's going to be able to translate this 3D shape into a whole bunch of kind of basically 2D shapes that are going to get layered on top of each other. And for our 3D printer, right now we're using the Prusa. They've got their own custom slicer, and I've put a copy of it because it gets updated on occasion. I've put a copy of it in the student share file. So if you open up your computer here, whatever you've got, and you're going to find a W drive. Yours is called student share, but if you see that W student share, mine's called collaboration, you're going to open that up and it will open up to a whole bunch of class folders here. And we're going to be looking for the Laird Robotics 11 is where I've put it in. So just open that one up there. And strangely, they give us four pre-done folders. I've put mine in assignments. That's one you can open up and run. It's going to open up there, and you'll see there is the Prusa 3D. That is the name of our particular 3D printer. You're going to open up the slicer and then go and find the prusaslicer.exe right there. I'll see if I can make a shortcut to it, but I've run into problems in the past with that. But once we open that up, we'll be able to bring in our 3D model. The first time you use this, you're going to have to set it up for yourself. So let me show you because it remembers mine. But here we should go to this configuration wizard. Should pop up automatically on yours. There we go. It should see a little bit something like this the first time you start. And you only have to do this once on each computer that you use. It'll remember you in the future. So really all we have to do is pick our printer. That's why it's nice that Prusa has made their own. Just click next at the beginning, and then you have to say which printer we're going to use. And they make a whole wide range of different printers. The mini's probably selected at the beginning, and I just want you to unselect that one because we have a bigger printer. We have this model here, the original Prusa i3 MKS and MK3S Plus. That's our first one here, and we have a 0.4 millimeter nozzle, so you're going to want to just click that to make sure that is the only printer selected. If there's any other ones they shouldn't be, you can deselect them as well. These are the only ones we have, and then you can click Finish. And that will set it all up for you so that we've got the right bed size and there's some custom settings and things, and you don't have to worry about any of that stuff. So next thing is getting your model in. And if you just go to your downloads folder, I downloaded, there's my Amazon, sorry, there's my Untitled 7 there. Let's bring that up again. Make it a bit smaller, there we go. And all you have to do is just drag it over onto the printer and you will see there is my, there's my shape. And just a quick navigation around here. It's a little simpler than SketchUp for navigating. You can zoom in and out with the mouse wheel. If you left click, this will allow you to rotate and look at all of the different angles. You can see that's the great shape there. Later on, if you need to, there are some customizable things here. For instance, if you've got a couple different objects, you might want to move them around so you can fit them all on the print bed. Here you can actually scale as well if it seems like it's the wrong size, if it's way too big, way too small. Be careful about this because you've probably given some exact measurements in SketchUp. So if you scale it, this is just scaling the overall thing. And you can see the full size, but you won't be able to make sure that the parts are all the right size. So I'm going to do that. You can rotate. We'll talk a little bit about why you might want to rotate later on, but you can rotate in any of the different axes. And you can flatten it on if it's on an angle. We'll talk about that a little bit later. And we can get rid of parts of it as well. This is kind of handy if you want to print two different halves and flip them over. Prusa will do that. I don't want to cut mine here at all. So there is our just kind of getting things ready and set up, and you want to make sure that it looks good and that things aren't overlapping if you've got multiple different parts. The next thing you have to set up is to talk about the print quality and something called supports before we do our slicing. The print settings is up here. Right now I'm set to draft. You might start off on this ultra detail. The smaller the layer height here, and that's what this little number is how thick each 2D slice is, the more fine the detail. And to be honest, for pretty much anything we're doing in robotics, for any parts and things like that, a 0.3 millimeter layer height is going to be just fine. We're not concerned as much with really smoothness as if you were to say design a figurine or a model or something and you wanted that just to be perfectly flat and smooth. We're really going for mechanical stuff, and you know, a third of a millimeter layer height, you're going to get these tiny little lines, but honestly, you're never going to notice them, and it's not really going to affect much. If you need to, you can go down finer. This just means that you vastly increase how long your print is going to take. So for me, in robotics, I'm using 0.3 millimeter draft as all the things. We have a PLA filament, so just leave this one here as it is. This is the kind of plastic that we're printing with. PLA is a bioplastic made from mostly corn. And the printer here is, of course, the IK3 that we've done. Now, two other things we need to look at and you need to concern yourself with is, do you need supports? And supports are something really, really cool that the printer is going to do for you and figure things out. But remember, what's going to happen is that each layer gets printed up on top of the next one. So depending on the shape, I just moved that out too far. Depending on the shape, you may have what is called overhangs. So for instance, on this particular shape here, this top right over here, think about what's going on when it's going to print. It's going to print a layer and then move down a layer and move down and move layer, move down. This is all going to be fine until we get to here, in which case we're going to be squeezing plastic out in a thin layer where this dark spot is. And there's nothing below to support it. So the plastic's just going to fall down or sag down because there's nothing, no foundation or base there. And in which case we can do two ways of fixing this. First of all, if I look at my shape, there's no reason it has to be printed this way. And if I were to print it, for instance, I'm going to rotate this here in a 90 degrees. Notice that as I move it around here, it allows me to, you can see the numbers that have been changing here. So I'm just going to rotate like so. Um, and that would be around the y-axis. So in fact, I can just type 90 degrees if I want. Oh, in this case, it would be, sorry, negative 90. And you can see now that that's face up. Also, though, be careful, make sure that I didn't, it looks like it might have fixed it for me. That's on the ground. Yeah, no, it did bring it up for me. That's nice. Notice that's exactly the same shape, and because now this little indentation is facing upwards like a pool, I could print layer, 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 and I don't have to worry about any kind of overhangs. So sometimes the overhangs can be taken care of just by reorienting or rotating your shape so that there's nothing, that the printer doesn't have to fight gravity there, essentially. We're working with gravity instead of against it. That's my first suggestion if you need to, is to pick a good direction. But sometimes it's just not possible. Basically, if I had say a side one here and I had another groove in here, well, there's no orientation that I can rotate it in where there's not going to be some kind of overhang. And in this case, we can create some supports. And essentially, the slicer is going to say, "Ooh, there's an overhang here. That's not going to work," and it will build in some like breakaway scaffolding, essentially, that is easier to clear out. They do take a bit more time, and you do get a rougher surface because you're going to break it off, but generally it does a great job. But if you can avoid using supports, avoid them. But most of the time, they're just not avoidable. We can make no supports. We can make supports on the build plate only. That would mean there's only things coming up from the bottom to the top. Or in this case, I want them everywhere because notice that I'm not going to need supports on the build plate. I'm going to need supports starting here, going up to this spot. So I'm going to put everywhere, and you'll see them later on. It's going to fix some math for you here. Just say, yes, I'm fine with that. The next part is the infill that you're going to need to worry about, and this is how solid the interior is. The default here is 20. That's pretty good, and that's going to be very strong. With a 20% infill, you could probably stand on a block like this, and it could support your weight. If you wanted a little bit faster and lighter, you could probably go down to 10%. Anything less than 10%, that interior is pretty hollow, and I wouldn't trust it for a lot of things. So I'm going to just leave it at the 15%, actually, I find is pretty good for some standard things. And we're good. So we've set that up. We've picked our draft. The plastic we've left alone. The printer we've left alone. I've built some supports in here. There's an infill. A brim creates a little layer around it. We generally don't need it for big flat things. It's only if there's very fine contact points on the ground. So I'm just going to leave that alone. And when you're happy, you can click this Slice Now. And what you will see now is that there's some big changes here. And now we get to actually see the slices. We change a whole bunch of colors. The printer tells us and colorizes things to say what different materials are, what different parts are. You can see here that this support has been built here to make it easy to break away, and it tells us that it's green. We also get to see, you can see the layers here. So you can see that we're made up of I think 123 layers here, and I can scroll down, drag that down. You can see actually how the printer is going to print it, kind of 2D layer at a time. So there's my ground one, and then it just slowly builds up. You can see that infill here is this square pattern, which means that 20% of it is solid on the inside. These green material is designed to be broken away and leave it nice and smooth, and it's just going to go up and up and up and up and up and up and print like so. And what we want to look at is this fine? Does this look good? Is all the pieces there that we would expect for when I print this? Because we can run into some weird problems a little bit later. But let's say I'm happy with it, and then we'll deal with some problems. If I'm happy with this and it looks good, it actually gives me a little estimate of time here as well, 46 minutes to print my little block, how much filament we're going to use, and in fact you can type in the cost of your filament so you can get an idea of how much plastic this is going to, how expensive the plastic is. I haven't set this up for the actual cost of our plastic, but you get to see the estimate of the time is a great one, and how many meters of filament we're going to be using of that plastic in our thing. When you're happy, you click this G code. This is a machining language that basically instructs the 3D printer where to move, how long to stay there, to heat up, to cool down, and is just direct instructions for how to move the machinery around. You probably never need to look at this, but you're going to need that file, and you're going to put it on a little SD card. So at this moment, you'd go grab the SD card from the 3D printer, get a little SD card reader from Mr. Laird, and plug it into your machine, and then you're going to hit Export G-code. When you plug it into your machine, it should pop up right here, and you would just give it a good name, because there might be a lot of files on there. So this particular one is not a great name, so I'll just call this Laird Box, and hit save, and then take that to the printer and load it up, and we'll go through that in class exactly how that's going to work. Now, let's say, however, that there was a problem, and there's going to be, I guarantee for a number of you, some issues. For instance, let's say if I took my model here and I made this was the piece that I wanted to create, and I've changed the design, and this is going to be a little peg that's going to fit into another little peg, or a little hole, and we're going to create a bunch of them. I'm going to download that still just to show you. And now I'm in the little slicing mode here. I go back to my 3D view, and I'm just going to delete that particular one and bring in the next one here. So there is my, oh, that's not the right one. Untitled 8. There we go, and you can see now you can see how we could have two different models here. I was going to get rid of that one and put this here. So this looks just fine, as you can see. Obviously, this is one where you're not necessarily going to be able to rotate it. If I were to rotate this up, then the hole is going to be needing some supports to support this back part. In this case, I'm going to need some supports here. I can't really think of a great orientation where I'm not going to need supports for this, so I would have to turn those on. But my settings should be great here, and if I then click Slice Now, oh, it got really smart, and it actually looks a lot better than I thought it was going to, but I can see there's going to be some problems with this print. If I look here, you can see there's some support material right there, and what I'm gonna, when I end up printing this is not going to be a solid piece. We're going to run into a problem here where this is one piece and this is another piece, and they're not actually going to be attached if I look really carefully. And in fact, if I zoom down a little bit here, you can see, that there is a wall here, that orange wall. So this is its own piece, and this is another piece. And in fact, notice that this is going to be two little cubes with a very flat little piece here. This is going to be totally empty. This is just going to fall apart, and your 3D print is not going to work. And the reason for that is, back in my SketchUp, I've created something that's impossible. And we talked about in class this dark gray area being the inside of a shape. So it's just not going to work because I've turned this inside out. So the 3D printer can't figure out how that needs to work. So be very mindful of testing out, looking at your 3D print before you do it. And then if you need some help, if it's not working out, you're going to have to go back and change some of the geometry. In this case, I would probably need to make some lines here to actually form this and have an exterior side. so that this could be joined together. And then we also talked about reversing faces. Now be wary on the inside what that's going to do. It looks like it's okay because I created those extra walls, but I'd have to reverse all these faces in order to make this this work. If you're running into problems, though, it can sometimes be a little tricky. Definitely ask for some help to make sure that your model is printable. And there I should be okay. Let's see, is that the right one? No, there we go. Perfect. And now I will have a fully shaped object, so it should all be joined together and work just fine. But that can be a little tricky solving those puzzles. Just I want you to be aware, definitely scroll through, have a look at how the layers are going to form to see, is this shape exactly how I want it to be before we end up spending an hour printing this and then realizing it just falls apart. Good luck and happy printing.